I want to solve some problems that have multiple steps and multiple fractions. In an earlier video, we talked about cross-multiplying and the idea of cross-multiplying. In this case, I wanted to talk about a different way to solve this, but I wanted to point out cross-multiplying only works when you have like a single fraction, you know, like this, equal to another fraction, something like that. The minute you add something to either side, like you add something else, it's not possible to just, cross multiply the fractions. That will not work. So instead, we've got to come up with a different method. But I want to point out that you could, using what you learned about fractions in elementary school and middle school, you could say, well, what if I got a common denominator, in this case on this side, so it was one single fraction, and then over here I have this one fraction. Then you could cross multiply. That would absolutely work. But I wanted to show a way that would maybe work more consistently and maybe cut some of the work down. The thing to look for is, can we find a denominator, a common denominator for all of our denominators? And the idea is, if we have one common denominator, if every single piece is being divided by the same thing, then essentially we can just ignore that denominator altogether and just solve the numerators. Because if they're all divided by the same thing, well, then only the numerator really needs to be solved. First thing I'm going to do, however, just let me make one pass through this, is I'm just going to get rid of parentheses. I would always do that first. So this will be 2x minus 6, remembering to apply that multiplication by 2. Now, one thing that I wanted to add here, because it's a little tricky, is a negative in front of a fraction. Okay, so I meant this negative right here to kind of be in front, because a negative in front essentially does this. I'm going to put like parentheses around that top there, and it basically puts the negative like that. That negative is going to apply to everything in the numerator. You could also instead apply it to the denominator, but since we need a common denominator, I really don't want to involve negatives. So we're going to have negative 3x and a negative 2. Okay. Now let's figure out a single common denominator for all of those things. The easiest way often is to multiply pieces together and then verify that they work. So for me, I'm going to look at these two and say, well, if I just multiplied 4 times 7 and got 28, then go over here, would that also work for this? It would. So what that means is this got multiplied by 7 to get 28. This got multiplied by 4 to get 28. And this got multiplied by 14 to get 28. Whatever you do to the bottom, you also have to do to the top. And remember, it would apply to the entire top. So I'm going to put some parentheses like this. Okay? So 7 times 3x is 21x. 4 times 2x minus 6 will give us 8x minus 24. Do not forget to apply that multiplication to both pieces. And then here, negative 42x minus 28. Now, all of this, I could write it this way, and maybe I will. All of this is divided by 28. All of this is divided by 28, like that. Because it is the same, because every denominator is the same, I can actually just ignore it. Okay? Now we can solve. We can combine our like terms. I would always do that first. No sense in doing too much work. So we got a 21x plus 8x. That is 29x. My method of solving these problems always gets them to the same spot, which is kind of my goal. So now let me get my x's on the same side. I'm going to add that 42x to zero it out on the right side. And for the interest of space here, I'm also going to add that 24 to zero that out on the left side. So we have 71x equals negative 4. And we'll divide both sides by 71. I don't think that reduces. Check with your teacher if they want a fraction or a decimal. I always like fractions. Negative, like that. If this video helped you, please like and subscribe for more math help. I have videos on algebra, geometry, calculus, statistics.